Rigid metal conduit, or RMC, installations sometimes require deburring, especially when shorts occur repeatedly. Several types of deburring tools are available to address this issue. Firstly, manual deburring tools are handheld and feature a rotating head with a cutting blade. These tools shave off burrs from the conduit edges and are suitable for smaller diameters and shorter runs. Secondly, electric deburring tools function similarly to manual ones but are powered by an electric motor. This provides faster and more consistent deburring compared to manual method. Thirdly, pneumatic deburring tools use air power for the highest speed and efficiency. These are ideal for large-scale projects involving extensive RMC runs. For RMC embedded in concrete, navigating bends and tight spaces requires specialized tools. Reamers have a flexible shaft with a cutting head. They are inserted into the conduit and rotated to remove burrs effectively. Power augers with deburring heads combine a rotating auger to clear obstructions with a deburring head to smooth the conduit edges. There are also specialized tools designed to be pulled through the conduit for deburring. Pull-through reaming tools have a spring-loaded head that expands as it is pulled through the conduit, removing burrs along the way. Deburring cables are flexible and have abrasive pads or rotating heads, which are pulled through the conduit to smooth the edges. When choosing a deburring tool, consider the diameter and length of the RMC runs. Ensure the tool is inserted properly and rotated in the correct direction to maximize its effectiveness. Always wear appropriate safety gear, including gloves and eye protection, when operating deburring tools. Carefully follow the manufacturer's instructions for specific tool use and maintenance to ensure safety and prolong the tool's lifespan. To further elaborate on manual deburring tools, these are often the most economical option for small jobs or when only a few conduit ends need deburring. The rotating head typically has multiple cutting edges to efficiently remove burrs. The user applies manual pressure and rotates the tool around the inside and outside edges of the conduit. It's important to apply even pressure to avoid creating uneven edges. Electric deburring tools significantly reduce the effort required for deburring, especially on larger diameter conduit or when dealing with a high volume of cuts. These tools often have adjustable speed settings to optimize performance based on the material and diameter of the conduit. The electric motor provides consistent power, resulting in a cleaner and more uniform deburring process compared to manual tools. Pneumatic deburring tools are the preferred choice for industrial settings or large construction projects where speed and efficiency are critical. These tools require an air compressor to operate and deliver high-speed rotation for rapid burr removal. Pneumatic tools are available in various sizes and configurations, including inline and pistol grip models to suit different applications and user preferences. When working with RMC embedded in concrete, the presence of bends and limited access can pose challenges. Reamers are designed to navigate these obstacles with their flexible shafts. The cutting head is typically made of hardened steel and can be replaced when worn. It is crucial to select a reamer with the appropriate diameter for the conduit being deburred to ensure optimal performance. Power augers with deburring heads are particularly useful when the conduit may contain debris or obstructions in addition to burrs. The auger clears the path while the deburring head smooths the edges simultaneously. These tools can save considerable time and effort compared to using separate tools for clearing and deburring. The auger typically has a spiral designed to efficiently remove material from the conduit. Pull-through reaming tools are an excellent option for deburring long runs of conduit, especially when access is limited to one end. The spring-loaded head automatically adjusts to the conduit diameter, ensuring consistent deburring as it is pulled through. These tools are available in various sizes to accommodate different conduit diameters. It is important to use a pulling mechanism that applies steady and even tension to avoid damaging the tool or the conduit. Deburring cables are another flexible option for deburring long or difficult to reach sections of conduit. These cables are typically made of braided steel with abrasive pads or rotating heads attached. The abrasive pads are suitable for smoothing the edges of the conduit, while the rotating heads provide more aggressive burr removal. It is important to lubricate the cable to reduce friction and prevent damage to the conduit. In addition to selecting the appropriate deburring tool, Several other factors can influence the quality and efficiency of the deburring process. Firstly, the sharpness of the cutting edges is crucial. Dull or worn cutting edges can result in a rough or uneven finish. Regularly inspect the cutting edges and replace them as needed. Secondly, the speed and pressure applied during deburring can affect the outcome. Excessive speed or pressure can damage the conduit or the tool. Start with a slow speed and moderate pressure and gradually increase as needed. Thirdly, proper lubrication can reduce friction and prevent the tool from overheating. Use a suitable lubricant for the material being deburred. Fourthly, cleanliness of the conduit is also important. Remove any debris or contaminants from the conduit before deburring to prevent them from interfering with the process. Fifthly, technique is essential. Use a consistent and controlled motion when deburring to ensure a uniform finish. Avoid jerky or abrupt movements. Sixthly, safety should always be a top priority. Wear appropriate personal protective equipment, including gloves, eye protection, and hearing protection. Follow the manufacturer's instructions carefully and never operate a tool that is damaged or malfunctioning. When working with an electrical conduit, it is especially important to ensure that the power is disconnected before performing any work. This will prevent the risk of electric shock. In addition to the tools and techniques described above, there are also several best practices for deburring RMC. Firstly, always debur both the inside and outside edges of the conduit. Burrs on either edge can damage the wires or cables being pulled through the conduit. Secondly, inspect the deburred edges carefully to ensure that all burrs have been removed. Use a magnifying glass if necessary. Thirdly, clean the conduit thoroughly after deburring to remove any metal shavings or debris. Use a vacuum cleaner or compressed air. Fourthly, protect the deburred edges from damage during handling and installation. Use conduit caps or end protectors. Fifthly, document the deburring process for quality control purposes. Keep a record of the tools used, the date of deburring, and the name of the person who performed the work. Lastly, provide training to all personnel who are responsible for deburring RMC. Ensure that they understand the proper tools, techniques, and safety procedures. By following these best practices, you can ensure that your RMC installations are safe, reliable, and long-lasting. The presence of shorts suggests insulation damage caused by sharp edges within the conduit. Deburring aims to eliminate these sharp edges, preventing future insulation failures and potential safety hazards. Different types of RMC might require slightly different deburring approaches. For example, galvanized RMC may require extra attention to prevent damage to the protective coating during the deburring process. Similarly, stainless steel RMC may require specialized cutting edges to effectively remove burrs. Consulting with an experienced electrician or electrical contractor can provide valuable insights into the specific requirements of your RMC installation. They can assess the condition of the conduit, recommend the appropriate deburring tools and techniques, and ensure that the work is performed safely and effectively. Furthermore, regular inspections of the RMC system can help identify potential problems before they lead to shorts or other failures. Look for signs of corrosion, physical damage, or loose connections. Addressing these issues promptly can prevent costly repairs and downtime. When pulling new wire through deburred conduit, consider using a wire pulling lubricant to reduce friction and prevent damage to the insulation. This lubricant can significantly reduce the force required to pull the wire, making the job easier and safer. Choose a lubricant that is compatible with the type of wire being used and that will not damage the conduit or insulation. Consider the long-term benefits of proper deburring when evaluating the cost of different deburring options. While manual deburring tools may be the least expensive upfront, they may require more labor and time, especially for large projects. Electric or pneumatic deburring tools may have a higher initial cost, but they can significantly reduce labor costs and improve efficiency. The cost of downtime due to shorts and other electrical failures can also be significant. Investing in proper deburring tools and techniques can help prevent these failures and save money in the long run. Remember to always prioritize safety when working with electrical conduit and deburring tools. Disconnect the power supply before performing any work, wear appropriate personal protective equipment, and follow the manufacturer's instructions carefully. By taking these precautions, you can ensure a safe and successful deburring process. The environment in which the RMC is installed can also affect the choice of deburring tools and techniques. For example, if the conduit is located in a damp or corrosive environment, it is important to use tools that are resistant to corrosion. Similarly, if the conduit is located in a hazardous location, it is important to use tools that are intrinsically safe. Consider the specific requirements of your application when selecting deburring tools and techniques. Staying informed about the latest advances in deburring technology can also help improve the efficiency and effectiveness of your RMC installations. Manufacturers are constantly developing new and improved tools and techniques to address the challenges of deburring RMC in various applications. By staying up to date on these developments, you can ensure that you are using the best possible tools and techniques for your project. Also, consider the accessibility of the RMC when choosing a deburring method. For conduit runs that are easily accessible, manual or electric deburring tools may be sufficient. However, for conduit runs that are difficult to reach or located in confined spaces, pull-through reaming tools or deburring cables may be the best option. Evaluate the accessibility of the conduit before selecting a deburring method. Another factor to consider is the material of the wires being pulled through the RMC. Some wire insulation materials are more susceptible to damage from burrs than others. If you are using wires with delicate insulation, it is especially important to ensure that the conduit is thoroughly deburred. Consider using a wire pulling lubricant that is specifically designed for use with delicate insulation materials. Furthermore, the size and complexity of the RMC system can also influence the choice of deburring tools. For small and simple systems, manual deburring tools may be adequate. However, for large and complex systems, electric or pneumatic deburring tools may be more efficient. Consider the size and complexity of the RMC system when selecting deburring tools. Remember that proper deburring is an essential part of a well-designed and installed RMC system. By taking the time to debur the conduit properly, you can prevent shorts, improve safety, and extend the life of the electrical system. Investing in proper deburring tools and techniques is a worthwhile investment that will pay off in the long run. Keep in mind that different jurisdictions may have different requirements for deburring RMC. Consult with local electrical codes and regulations to ensure that you are in compliance with all applicable requirements. Failure to comply with these requirements can result in fines or other penalties. Always prioritize compliance with local codes and regulations when installing and maintaining RMC systems. Finally, consider the environmental impact of the deburring process. Some deburring tools and techniques may generate dust or other pollutants. Take steps to minimize the environmental impact of your deburring operations. Use dust collection systems, recycle metal shavings, and dispose of waste materials properly. By considering the environmental impact of your deburring process, you can help protect the environment and promote sustainable practices. By carefully considering all of these factors, you can choose the right deburring tools and techniques for your RMC installation and ensure a safe, reliable, and long-lasting electrical system.